Hello there, this is Professor Eckhouse, and I'm going to continue our conversation from earlier today about fractions. And this next section is section 4.3, and it is about multiplying and dividing fractions. You're going to find that this is probably a lot easier than what we did before. There was a lot of information in section 4.2. So the objectives for this are to multiply fractions and rational expressions, evaluate powers and square roots of fractions, divide fractions and rational expressions, and solve applications. So we're going to start with multiplying fractions. So first I'm going to show you a demonstration of multiplying fractions using an array. You can click this link here, right here in OneNote later if you want to play with this. So this is what this is a demonstration of what multiplying fractions really means, and a lot of students are like, what does it mean when I take 3/8 of 5/6? Well, this is what it means. So if you have 3/8 here, it's divided into 8 sections, and 3 of them are shaded. The other one is divided in the other direction into 6 sections because it's 5/6, and 5 of the 6 are shaded. So now I'm going to click Go. And they come together and they overlap. The ones that end up being this fuchsia color here are where the two sections overlap. And you can see that now there are 8 by 6, so there's 48 sections here, which is the common denominator of 8 and 6. And when you multiply them, what you're left with is this portion right here, which is 1, 2, 3 by 1, 2, 3, 4, 5. So there's 15 here. So when you multiply these together, you get 15/48. All right, so you might want to come look at this again later. All right, so continuing on, the way you actually multiply fractions is you set them side by side and you multiply the top. So you would get on this right here, A over B times C over D, you would get AC on the top. So AC here. And on the bottom, you would get B times D, or just BD, however you want to write it. So A times C over B times D. Okay, so next I'm going to show you some examples of doing these problems. The first one is 3/7 times 2/5. And we're not looking at simplifying yet. These are all just going to be very straightforward. So we multiply the top to get 3 times 2, which is 6, and multiply the bottom, which is 7 times 5, 35, and that is it. That's all you have to do for those, as long as they don't need to be simplified. The next one is -1/6 times 5/8. So we've got a negative times a positive, so make sure you don't forget the negative. 1 times 5 is 5, and on the bottom we get 48. Okay, so they're that straightforward. The next one is 2 negatives, so don't forget to write those down. 2/3 times -2/5. Okay, so the negative times a negative makes a positive, and on the top we get 4, and on the bottom we get 15, 4/15. Okay, next I have some here for you to try. So I've got them all lined up and ready to go. All you have to do is fill it in. So why don't you give these a shot? Pause the video and try them all, and then when you turn it back on, the answers will pop up. Okay, here's all of the answers to those problems. Double check if you have any questions. Make sure on B it's negative and on C it's positive, because 2 negatives multiplied together make a positive. Okay, so this next section we're talking about multiplication with simplifications. We're going to multiply and simplify, and the method that I teach is to simplify before you multiply. It just seems to make it easier to find the things, the factors that you need to cancel out, instead of having huge numbers and then trying to make them small again. So, but you can do it the other way. It's in the book if you want to go take a look at that. So something I want to remind you of, or maybe teach you if you don't know this, is that 12 times 35, 12 over 25 times this other fraction is the same thing as saying 12 times 35 all over 25 times 36. It is the same thing, which means we can cancel or divide out across 12 and 36. So I'm going to rewrite this, looking for some factors that I see in common from the top to the bottom. So I know that 12 and 36 both share 12, 35 and 25 both share 5. So I'm going to go ahead and take those numbers out. So I get 5 times 7. And again, like I said last time, this requires some practice with factors and the multiplication table. So 25 is 5 times 5, and 36 is 3 times 12. So I see some factors that I can cancel out here or divide out. I've got a 12 on top, a 12 on the bottom. I've got a 5 on top and a 5 on the bottom. And I don't see anything else that I can divide out. So on top I'm left with a 7, and on the bottom I'm left with a 5 times 3, which is 15. All right, the next one, I'm going to do the same thing. I've got, I'm going to make one big line, and I'm going to put all my factors. So this time I'm going to skip a step. It's very hard to make straight lines on a digital pen. So I've got, see, 22 and 44 both are divisible by 22. So I'm not even going to factor those because I see what's going to happen there. And 15 and 39, looks like they both have a 3 in them, maybe. So I've got 3 times 5 times 22, and 44 has 2 times 22. So see how I looked for a 22? I looked for something that they had in common. And then 39 is 3 times 13. So again, looking for things that they have in common, factors they have in common. So I've got a 3 here and a 3 here. I'm going to divide those out. A 22 and a 22. And then I'm left with a bunch of, well, prime numbers, and none of them are the same. So on top I get a 5, and on the bottom I get 2 times 13, which is 26. Okay. All right, the next one is going to be positive because I've got a negative times a negative. So I get to drop that negative and not have to write them anymore because they cancel out, or they negate each other. So I've got, let's see, I've got a 9 and a 27. Well, I know 9 goes into 27. And I actually know 8 goes into 40. So I'm going to leave 8 and 9 unfactored because I see that 9 is going to go into 27. So I've got 9 times 8. And I remember I said that 8 goes into 40. So I get 5 times 8 times 27 is 3 times 9. Okay, so you just have to think about it before you start, or you can do prime factorization, which takes a little bit longer. So the 9s cancel out. The 8s divide out as well. And on the top, I am left with a 1. So there's nothing left on top, but that does not mean that it's 0. It just means that it's a 1. Okay, because when you divide these out, you're left with 1 and 1, really. Okay, so you get a 1 on top, and on the bottom you get 15. So this is 1/15. All right, so next we're going to look at some problems. I just got cut off, so I have no idea where I got cut off. I'll say that again. These are for you to try, and when after you try it, come back and the answers will be here. Okay, so here's the answers. Of course, this is not the only way to break everything up and get it to cancel out properly. In some cases, you might find a different way to do it and end up at the same answer. Make sure you know that the top number here is 1, not 0. So when all the numbers go away on top, they're really 1s when you are dividing things out, because 4 divided by 4 is 1/1. Okay? So I'm going to be moving on to multiplying rational expressions. Okay, so we're going to be multiplying these rational expressions, and as you can see here, there's a lot of x's and y's. So as I've shown you before, crossing these out, I haven't taught you the exponent rules yet. So it's easier to just show every x and every y, so you can see how they're going to divide out. And when you learn the exponent rules, you won't have to do this. So on the top, we've got x times x times 6, which is 2 times 3. And the reason I did that is because I see a 3 down below, so I know I'm going to have to factor those out. And then I've also got a y times a y times a y times a y. That's the whole top. And you can put that really in any order because we're just going to divide things out. And then we've got a 3 times a y times a 5 times an x. Okay, so now we're going to go back and figure out what divides out. So 3 divided by 3 is 1/1. X over x is 1/1, and same with y. Okay, so what we have left is what we have to put back together. So the numbers always go first, so we write the number first, 2, and then the letters go in alphabetical order. So the next thing is going to be that 1x, there's only one of them, and then we've got y times y times y, which is y to the third. On the bottom we have a 5, so this is going to be 2xy cubed over 5. So pause there and take a look at that. If you don't understand, back up, listen to it again, and keep working on these until you understand them. All right, so the next one is 4a squared. So I've got 4 times a times 15. I see the bottom has some 9, which has a 3, so I'm going to go ahead and break this up into 3 times 5 times b. Okay, so that was 15. 3 times 5 times b. Okay, so I'm breaking everything up into its, basically into its prime factorization. So the 9 is going to be 3 times 3, and the b squared is b times b. And then the 16, I'm only going to go down to 4s because I see there's a 4 up there. I don't have to go all the way down to prime. You can if you want. It won't hurt anything. And then I've got an a, 16a. So 4 times 4 times a. Notice I didn't do 2 times 8 because I see that I have a 4 up here. So pay attention to what you're doing so you can see what it is you need to factor it into. Or go all the way down to prime, and that's fine too. That'll always work if you do it right. All right, the 3's divide out, the 4's divide out. Let's see, I have an a to divide out. I have a b to divide out. And what I'm left with, I'm actually going to circle so I don't mess it up. So I've got an a on the top, I've got a 3 and a b. So I think what I have here now is 5 a. Oops, look at that. I forgot a 4. There's a 4 right there. 5a on top. I didn't circle the 5, so I'll try to be thorough. I've got a 5a on top. Remember, the numbers go first. And then I've got 3 times 4 times b. So 3 times 4 is 12. And there's just one b, so I just write b. All right, the last one, I've got 8m. All right, so 8m, when I'm dealing with, actually I'm going to make that a 4 times 2 because I see right there that there's going to be a 4 on the bottom. But when I'm dealing with fractions and I have a whole number, I want to put it over 1 so that I line everything upright. So instead of how they have it written right along the line there, the fraction bar, you want to put it up above so it's even with the 3n. All right, and I've got that times a negative. So I'm going to put the negative, I'm going to end up putting the negative out front because all of this is going to be in one big fraction. So the negative is going to be out here. Okay, so the negative can come back to the front. All right, sorry, I'm kind of making a mess here. And then I've got 3 times n. And on the bottom, I've got 4. I've got a 4 on top, so I'm going to leave it as 4. And then m squared is m times m. So sorry, sometimes you make big messes as you do this. And sometimes you'll screw up, and so I would do it in pencil or in OneNote so you can erase it easily. I've got, let's see, I've got an m that divides out, and I've got a 4 that divides out. And it looks like I'm left with a negative, and then 2 times 3 is 6, and there's an n there. So again, you can go circle all that if you want to. And on the bottom, I've got a 1 times m, which is just going to be m. So that's the final answer, negative 6n over m. All right, so I have some here for you to try. So give these a shot. It might take you a little while. So pause the video and try them, and then I'll have the answers up here in just when you turn it back on. Okay, so here is my work. On the first one, I circled what I had left, but I didn't do it on all of them because I didn't want to make it too messy for you to be able to see what I'd done. So what I did was, again, I looked for the factors that I saw on the bottom and the top together. So 5, I saw 5 and 15, so I made it 3 and 5. On 4 and 8, I saw that 4 goes into 8, so I just left it as 4 and then 2 times 4. And then I went through and I divided everything. Again, you could do prime factorization if you would like. So take a moment looking at this, try to figure out what you did right and what you did wrong. Go back and try to fix the things you did wrong without looking too closely at mine, and then see if you get it right. All right, I'm going to be moving on to the next subject. Okay, now just a little reminder, we're talking about evaluating powers and square roots of fractions. So the rules apply just the same that we've talked about with powers and square roots. But I just wanted to give you a reminder that 5 times 5 times 5 times 5 equals 5 to the 4th. Okay, so not 5 times 4, because that would be 5 plus 4. sorry, 5 plus 5 plus 5 plus 5. So make sure you understand this, that times, when you multiply something multiple times, that's what that power means. The exponent tells us how many times the number is multiplied. So make sure you have that straight. Multiplied. All right, so exponents of fractions. So in this first one, we've just got a 1/2 cubed. So 1/2 is shown as cubed. And what that means is that we've got 1 cubed over 2 cubed. So the cubed applies to both the 1 on the top and the 2 on the bottom. And so 1 cubed is just 1 times 1 times 1, that's 1. 2 cubed is 2 times 2 times 2, that is 8. Okay, so make sure you understand how to use these powers. We need more space here. All right, so B, we've got -3/4 to the second. Okay, so first let's think about what's going to happen with the sign. I've got negative times negative, because what this means, remember, is -3/4 times -3/4. So when the power is even, it becomes a positive. So this is going to be positive. And then we've got 3 squared on top and 4 squared on the bottom. Okay, and we don't even need the parentheses anymore. I didn't need to put those. So I've got 3 squared is 9, so 3 times 3, and 4 times 4 is 16. All right, C is, again, a negative, -2/3 cubed. Now, we've got a negative cubed. What that means is a negative times a negative times a negative. And that is going to give us a negative, because these two become positive, but the third one doesn't have anything to cancel it out, if you want to think of it that way. So anything to balance it out to positive. So it's going to be a negative. All right, so the answer is negative. And then we're going to have 2 cubed over 3 cubed. Now notice I put the negative on the outside because I didn't have to think about it anymore. I know the answer is going to be negative. I'm just going to keep the numbers. All right, so that means that I've got -2 times 2 times 2. So remember that's what 2 cubed means, and 3 cubed means 3 times 3 times 3. So -2 times 2 times 2 is 8. 3 times 3 is 9, times another 3 is 27. So 8/27. And it's negative. All right, so take a look at those, pause it, spend some time on it if you need to, and next we're going to look at some problems for you. Okay, here are the problems that I want you to look at. There are 3 of them here, so watch your negatives, watch the number here, and make sure you distribute it amongst the top and the bottom. Okay, so here are your answers and a little explanation. There's not much explanation for the last one, but just make sure you use that cubed that's on the fraction on both the top and the bottom. And remember, 4 cubed does not mean 4 times 3. It means 4 times 4 times 4. So 4 times 4 is 16. Take that times 4 and you get 64. Because the negative is multiplied times itself 3 times, a negative times a negative times a negative, I end up with a negative as an answer. Okay? So that's how I end up with a negative over here. The negative here cancels out because I have 4 of them. So an even number of negatives makes a positive. All right, so try those again if you got them wrong. So the same rule applies. I may have forgotten the rule last time, but I showed it to you by example. When you take the square root of a fraction, you're taking the square root of the top and the square root of the bottom. So when I have the square root of 9 over 49, that's our first one. What that means is the square root of 9 over the square root of 49. If you don't know your square roots and your squares, use the multiplication table that I gave you here in OneNote, print it out, and highlight all the perfect squares. All right, the square root of 9 is 3, and the square root of 49 is 7. So the answer is 3/7. All right, the next one is the square root. Oh, I should probably write that a little bit bigger. The square root of 45 over 80. So the first thing we're going to do with these is we're going to simplify, and then we're going to work on taking the square roots of them. So 45 factors to 5 times 9, and 80 factors to 5 times 16, and because this is a math book, a math problem, they made it nice for us so that we can see when we do this, we end up with the square root of 9 over 16. What that means is the square root of 9 over the square root of 16. And the reason I didn't break it up first is because I saw that 45 wasn't a perfect square, and I saw that 80 was not a perfect square, and that they were factorable. So you just factor it until you can factor out a perfect square, and that's what you're looking for when you go to factor it. So again, the multiplication table will help you find those perfect squares if you don't already know them. So this one becomes the square root of 9 is 3, and the square root of 16 is 4. Okay, so this next one, square root of 75 over 3, and again, I see that neither one is a perfect square. So I'm going to try simplifying this, and I get 3 times 25. So again, use the clues that are there. I've got a 3 on the bottom, so look for a 3 as a factor on the top. And I'm going to cancel out the 3's, and I end up with nothing on the bottom, just a 1 basically. So I end up with the square root of 25 over 1, or just square root of 25, which is just 5. And in this, where we're working on right now, you don't have to report both the positive and negative on these square roots. Okay, now it's your turn to try it. Give these all a shot, and then you can turn it on and see how to do them. Okay, so I put all the answers here except for the second one. The first one is just the square root of 16 over square root of 25, which is just 4 over 5, not 25. So 4 over 5. So the square root of 25 is 5. The next one, I saw that both of these have a 5 in them, and once you take the 5 out, you get a perfect square on the top and the bottom. So you want to take the top 20 is 4 times 5, the bottom is 25 times 5, and you're going to divide out those 5's. And then you end up with the square root of 4 over the square root of 25, which is 2 over 5. And then the last one is just 98 over 2 is 49, and that's a perfect square, so you get 7. All right, the next section is dividing fractions and rational expressions. So this rule is hopefully a reminder that when you divide by a fraction, you multiply by its reciprocal. So notice that this is the reciprocal of this, okay? So that's what you want to be doing when you divide by a fraction. So let's practice some of these. All right, so the first one is, let me insert some space here. The first one is 4/3 divided by 2/9, which means 4/3 times 9/2. So you're going to take this and you're going to flip it over and get 9/2. All right, so now we can simplify. So I'm going to rewrite this as simplified. So 2 times 2, and then 9 is 3 times 3, simply because I saw a 3 and a 2 on the bottom. I knew I was going to be doing that. 3 times 2 is on the bottom. So I just put all of this over one fraction. So one of the 2's cancels out or divides out, and one of the 3's divides out, and I end up with just 6 over 1, which is just 6. Okay, the next one, B, is -5/6 divided by 5/8. So I'm going to rewrite this as -5/6 times 8/5. All right, so again, we've got a negative. There's just one negative, so the whole thing is going to be negative. So I've got 5 times 2 times 4 on the top, and I've got 2 times 3 times 5 on the bottom. So my 5's are going to cancel out. My 2's are going to divide out. Divide out, cancel out means the same thing. I'm just trying to get you to get used to using them interchangeably, and divide out is a better word, actually. So we end up on top with 4 over 3 on the bottom, and don't forget your negative. All right, C, each of these is just a little bit different. So C is 8 divided by 4/3. So I'm going to rewrite both of these. So I get 8 over 1 times, and then I'm going to flip, take the reciprocal of 4/3, which is 3/4. So I switched it to a times, which means I need to switch it to the reciprocal. All right, so now I've got 8 is 2 times 4, and then I've got 3 for 3/4, and then 1, which I don't need to write, but I can, 1 times 4. It doesn't matter when you've got it in a times, because 1 times 4 is still just 4. But the 4's now are going to divide out, and I'm left on the top with 6, and on the bottom a 1, so again I get 6. All right, D is 4/9 divided by 2. So remember, divided by 2 means divided by 2/1. That's the same thing. So the reason I did that is because we're taking the reciprocal, and not everybody knows that the reciprocal of 2 is 1/2. So if you put it over 1, it's a little easier to see that it becomes 1/2. So remember, I times it, and I take the reciprocal of 2/1, which is 1/2. All right, so 4/9 is the same thing as 2 times 2 over 9, and I didn't factor the 9 because I don't see anything else on top to divide it out with. And I've got a 1, so I'll go ahead and write it, although you don't need to, and the 2. All right, so I've got the 2's are going to cancel out or divide out, and on the top I'm left with a 2, and on the bottom a 9. So that's our final answer on that one. All right, for the sake of time, I did not show, I did not give a bunch more tryouts for you, but there are going to be a lot in the book for you to try. Okay, so now this is taking everything we've just talked about and kind of putting it into one kind of problem. So we're now dividing rational expressions. So we've divided fractions, we've multiplied rational expressions, we're putting it together. So I'm going to take this step by step. So I've got x squared over 2y divided by 8x over 5y. So that's going to be x squared over 2y times, so now I'm switching it to a times, and I'm going to take the reciprocal of this because I'm multiplying instead of dividing. So I get 5y over 8x. So now I need to write everything out so I know how to cancel things. And I've got x times 5 times y on the top. And on the bottom I've got 2 times y times 8 times x. And I did not factor out the 8 because I saw that there was nothing for it to cancel with on the top. So I've got x's top and bottom, and I've got y's top and bottom, and I don't see anything else that's going to factor here. So on the top I get 5x, and on the bottom I get 16. So anytime I go too fast, remember you can rewind and watch it again or pause. All right, so the next one is negative 4n over 3m divided by 2n. So I'm going to say 2n over 1. Because anytime you're working with fraction, multiplication, division, addition, it's just easier to put it over 1. All right, so I'm going to rewrite this as negative 4n over 3m. So that's still the same. And then I'm going to say times 1 over 2n. So I just took the reciprocal of this one. Now I'm going to rewrite it with factorization, and you could have done that all in one step if you wanted to. 2 times 2 times n times 1, so you don't need the times 1, over 3 times m times 2 times n. Right, so now I'm going to divide out the 2's. I'm going to divide out, the n's and the 2's, and everything I'm left with, nothing else divides out. So I get negative 2 over 3m. Okay, so the next thing we're talking about is finding a fraction of a fraction. So this is just turning English into math. So 1/4 of 20 means 1/4 times 20. Okay, which a better way to write that would be 1/4 and use the dot so it doesn't look like an x times 20 over 1. So 1/4 of 20 is going to be 5, but so we can do this a long way, and we get 1 over 4 and then times 4 times 5 on top, and then you can have the 1 on the bottom. The 1's don't really matter, and our 4's cancel to end up to be 5. So that's the long way. But you might see that 20 divided by 4 is 5. All right, so 1/4 of 2/5, similarly, so that's using just one fraction, but what we're going to see in this section is this. 1/4 of 2/5 means 1/4 times 2/5. Okay, so we get 1 over 2 times 2, and then we're just going to extend the fraction bar and have 2 on the top and 5 on the bottom, and you can see that our 2's are going to divide out, and we end up with 1 over 10. So 1/4 of 2/5 is 1/10. Okay, so an example of a word problem that you might see is if 3/4 of the fish in the pond are bass and 2/3 of the bass are under 8 inches in length, what fraction of the fish in the pond are under 8 inches in length? So what they're telling us here is that 3/4 of the fish are bass, and of those 2/3 of the bass are under 8 inches. So we're finding 3/4 of 2/3, or the other way around would work too. So 3/4 of 2/3, which means 3/4 times 2/3. And if we work this all the way out, we're going to get 3 times 2 on top, and then the bottom we're going to get 2 times 2 times 3. And if we look at how this is going to divide out, the 3's divide out, the 2's divide out, we're left with a 1 on the top. So don't forget that 1, and that is 1/2. So what this means is 1/2 of fish are bass under 8 inches in length. Okay, so the last thing that we are looking at is an area of a triangle. And I wanted to remind you where this comes from. So remember that the area of a rectangle is base times height. And if you look at the area of the triangle, it's half of that. So the area of the triangle, as you can see here, is half of the area of the rectangle. So the area of a triangle is 1/2 times the base times the height. Now, how do you do that if it's not a perfect triangle? So this one here, the height is obvious. It's here on the left. It's a right angle. It's easy. This one, the height is from the highest point down to the base, coming down at a 90-degree angle. So you also have to have a 90-degree angle right here. But this one, you have to drop the line on the outside right here, and it still has to drop down at a 90-degree angle. The base is still only from here to here, and the height is from the tip of the third corner down to the same line that this is, as if it were sitting on a table. It was a lot, so make sure you practice on these so that fractions can feel more comfortable to you, since you will be seeing them quite a bit. All right, thanks for watching.